All right. So welcome everybody to the third session in our Getting Started with Splunk mini-series. We're very happy to have you here today. This is the third out of 5 sessions in this mini-series, the core mini-series. Before we get started with the actual session, I do have to let you guys know that this presentation may contain some forward-looking statements regarding our products and our technology. Just make sure that you don't make any financial decisions based exclusively on those forward-looking statements, because as we all know, the future can always change. So we want to make sure that we put this out there to make everybody aware that we have intentions of any forward-looking statements we make are what we intend on doing right now, but if something changes, we don't want you guys to make a decision based on that. Now, for you guys to get a little bit of context on the voice behind the screen, this is me. I'm Alexia Perez. I'm a solutions engineer here at Splunk. I have been at Splunk since 2021 when I started as an intern. And ever since I graduated, I've worked here full time, focusing mainly on our core and security products. So today we're going to be talking about our core platform, but if you ever see me in another session, odds are you are at a core or security session. Now, for the series agenda, if you've participated in the previous 2, you will know that the first one covered importance of machine data, and the second one we talked about the Splunk platform and its architecture on the back end. Today, we're going to talk a little bit about the SPL language, so the Splunk processing language, how it works and how the syntax of it works. And we'll take a look at that today. And then in future sessions, we'll talk about knowledge objects and popular commands. So stick around to learn about all those different concepts. And today we'll specifically focus on, like I said, the SPL syntax. We'll take a look at the format of the syntax, the different search modes we have available, different things we can do with SPL, like comments and different command types, and how Splunk processes all of this in the background so that you guys understand why the syntax is the way that it is and why you should use SPL in the way that we recommend in best practices. It'll all make sense based on how Splunk processes all of that information. So with that, we'll go ahead and start here with the SPL, the search processing language. So here, we have the syntax of what a command in SPL would look like. So the search processing language is going to allow us to search, correlate, analyze, and visualize all of our data. The correct syntax is shown on the slide. So if we go from left to right, you'll notice that we always want to start our queries with some basic search terms just to help us narrow down the data set that we're actually working with. So we have tons of data in our environment. We have gigabytes and gigabytes or terabytes and terabytes of data. We don't want to apply their commands and analytical functions to all of that data at once. That would be way too expensive. So we're going to want to always narrow down the events that we actually want to focus on before we apply those commands. And that's going to be the first thing we need to learn here. And so for that reason, we always have those search terms, which this box has been cut out a little bit, but you can see that this is the search terms right here on the left-hand side. You're going to specify all of those keywords, value field pairs that you need from your events. And then after that, we're going to always use what we call pipes. And this pipe character is going to indicate that command is coming next. So if we look at the back end, this is how it's going to work out. We're going to start focusing on the events in our environment where the action field, in this case, is equal to a value of purchase. And so this tells Splunk, hey, look at that keyword purchase, but only in this specific field. We're not looking for the keyword anywhere in the event. We're not looking for the keyword to just exist somewhere. We're looking for that keyword being the value of that field. And that is the best way that we can specify these key value pairs, these events at the beginning, is by using their field and the values for those fields. It's going to be the most efficient way to do it. So we do that in the beginning. And in this case, in the background, what Splunk is doing is, okay, so from the events that I have available, I'm going to extract all the ones that are action equals purchase. So these are all those events where the action field equals purchase, but we're not returning those results yet because the user then put a pipe and then put a command. This command we'll talk about in more detail in the 5th session, but this command is going to do a statistical calculation here, and it's going to count the number of events and organize them by the status field. So what Splunk is going to do next in the logic on the back end is take these events where the action is equal to purchase, and from these events, we're going to start counting for each status available in these events, how many events available do we have? And then we're going to start counting that. Then at the end, we have another command, and this one's going to it's called rename. It's going to rename this field count as number of events. So in the back end, Splunk is going to take these results and it's just going to rename that field up here. So what we're actually returning to the user is going to be this right here. So you run this query and this is what you get in the results. But this is the logic that Splunk followed in the back end. And that is why we should narrow down those events at the beginning so that we can apply all these functions on top and make it as efficient as possible and not cost us too much in terms of efficiency, in terms of CPU and energy, etc. So we're using the least amount of power in order to get from here to there. If we did it opposite, we would use a lot more memory in order to retrieve all of the events we have available, do these calculations, and then narrow them out at the end, right? So that's why we want to do this in this order. And now that you understand that syntax, you'll be able to write those better, more efficient searches. But in order to do so, you're going to want to pay attention to the search mode that you're running your searches in. So there's 3 different modes that we're going to have available. And this is a setting that's going to optimize your search performance by controlling the amount or the type of data in the search that is going to be returned. So the fast mode is going to speed up your searches, as you may imagine, and it's going to do that by limiting the types of data that are returned by the search. Now, the verbose mode is going to return much more event information at the expense of a little bit slower search performance. And then, of course, we've got the smart mode, which is a little bit of an in-between, a balance in between. This is the default setting, and it's going to toggle the search behavior based on whether your search contains transforming commands, which we're going to talk about in a second. For those types of searches, it'll behave like fast mode. For searches without those transforming commands, it'll behave like verbose. So it'll kind of pick and choose how it behaves depending on the type of search you're running. So these are the 3 search modes. And then, of course, we have the ability to comment. So we actually have the ability to comment in any of our SPL searches. So as you start building these queries and they get a little bit more complex, you may want to start testing them in pieces, and you may want to start adding those comments for additional context in your queries. And to do that, there's a few different ways you can comment, but the most popular one is to actually use the backtick. If you use 3 of them, you can actually start typing in between the backticks right there, and you'll see that it's grayed out because it's all a comment. And so when you open those backticks, you can start typing, and until you close them, everything you put in there is going to be a comment. So that is how you would use comments in your SPL queries, and they're going to be super useful, especially as you get into those more complex searches. And then, of course, like I said earlier, there's different types of commands in SPL. And we mentioned transforming ones just a second ago, and you may have been sitting there wondering, what is a transforming command and why do we seem to care so much about whether or not our commands are transforming? And so as you learn more about SPL, you might hear those terms of these different keywords we have on the screen. These are all different types of commands. So we may hear things like streaming, generating, transforming, orchestrating, data processing, etc. And those are all different types of search commands. And we're not going to discuss all of those in much detail today, but there are going to be 6 broad categorizations for almost all of our search commands. And those 6 are going to be the distributable, streaming, centralized streaming, transforming, generating, orchestrating, and then dataset processing. These are not mutually exclusive. So some commands are going to fit into one category only. Some others are going to fit into more than one. So for instance, the stats command we saw earlier, that command fits only in the transforming category. Other commands can fit into multiple. For instance, there can be commands that are streaming and also generating. And so we're not going to worry too much about what all that means right now, but we're going to focus on these specific ones we have in that square right there. So these are the commands we're going to be talking about today, the streaming and transforming. And so streaming and transforming commands, just for the purposes of today's session, we're going to focus on those 2. And the streaming commands are going to operate on each event as they are returned by search. So essentially 1 event in and 1 event out, or no events out. So for example, there's an event called eval, a command called eval, and that eval command works kind of like setting a variable in a programming language. It'll create a new field. For instance, let's say the new field we create is called full underscore name, so full name. And that field would contain the combination of the value in the first name field plus a space plus the value in the last name field. So we see that we've taken values from other fields, we've put them together, and now we have created the value of this new field. And that's kind of how eval works. So that would be a streaming command. Then a non-streaming command would require the events from all of the indexers before the command can operate on the entire set of events. So many transforming commands are going to be non-streaming, and using non-streaming commands early in your searches will help reduce parallel processing. So for instance, before we can sort a list, we have to have the full list of events, right? So before the sort command can begin to sort the events, it'll have to see the entire set of events has to be received from the indexers before we can sort them. We're going to see an example of this in a more visual way here in the next couple of slides so you guys can understand it better. But these are the main two types of commands that we're going to be working with, especially towards the beginning of our SPL journey. So we're going to go ahead and look at that example next so that we can better understand how these commands are processed. So here we have this visual. We have a search at the top of the screen right here. So we've got some search, and that search will have some key value pairs. It'll have some keywords of the events that we want to actually focus on. And then we have a few different commands. We have a lookup one, we have a where command, we have an eval, which we briefly talked about. And then all of a sudden we see, boom, we stop here because we have a sort. So up until this point, we can process these commands kind of as they come, but the sort requires us to get everything that we need from our indexers before we can actually sort it, right? So that's kind of how what we explained up until this point. Now we're going to see how this works here on this diagram, based on what the indexers are sending back, right? So the search is sent to the search head right here by the user. We send this query into the search head, and the search head is going to distribute that into the indexers to be able to process as much of the query as possible before we return. Now, for the events that are on each of these indexers, the indexer is going to process the search until it encounters a non-streaming command, so the sort, right? So in this example, the indexers will process the search through the eval command, and then it'll perform the sort, and all of the results must be sent to the search head to then be processed as results. So the sort command will use the name field. It'll use we have these name fields with people's names, and that's what we're using in sort. We're using that name field, right? So we know that the sort will use that field. And if you imagine that the first indexer is going to return these two names, Alex and Maria, then the second indexer is going to return the name Wei. And then the next indexer is going to return Claudia, David, and Eduardo. The results that are on each indexer can be sorted by that indexer. We can still run the sort command for each of these lists, and each of these can be sorted on their own, but then they're all going to be returned back to the search, and we're going to have to sort it all as one big list, right? And that's what we, so this pre-sorting we do here, that's what is referred to as pre-sort. And so now if we transition over, so now we take these lists that we've evaluated all the way through that sort, we've done a pre-sort in the indexer, so now we bring it back to the search head, and now the search head gets all of this list of names, so we still have to go ahead and run that sort on that list to actually finish sorting the entire list of names before we can continue to the rest of the commands. So now you can kind of see why putting a command like this towards the end of your query is going to be more efficient than putting it at the beginning. Because if you put it really early in the beginning, we're going to have to stop what we were doing in those indexers, send it back to the search head, and then the search head is going to have to do all of that processing and finish the rest of the query. And we know the search head is going to be slower to process things than our indexers would. So we want to make sure that we process as much as possible in the indexers before we move on to sending things to our search head. And then at this point, we'd get the results in the search head. The search head would finish sorting them, then would apply the last few commands, that where command there at the end, and then our final results would be then returned back to our user. And that is how SPL is processed in the back end. And that's why those different types of commands are important. We have to pay attention to the types of queries that we're building. But if we do the best practices, if we put these commands later in our queries, we can ensure that we're being as efficient as possible, and we can run really, really fast, really productive SPL queries. And now, of course, we've got some tips here for writing those better, more efficient searches. So if we look at the big picture, how can you run better searches and what does that entail? So when you're trying to perform fast and efficient searches, one very important thing to think about and remember is the index and the time range that you're searching on. So that'll be one big clue that helps you narrow down those events as much as possible, is the index that we have those events in and the time range that we're searching on. Additionally, it's super important to think about the values that are unique to your events and search for those whenever possible, especially if those values are parts of specific fields in your events. Because ultimately, the idea is to reduce the number of events that are filtered after schema on the fly. So after the indexing. Now, choosing a time range that is as small and specific as possible is going to be the best practice. So if you're looking for events that happened in the last 15 minutes, obviously we don't want to be looking at the last 24 hours just because it was the default that came up on the screen. We want to make sure that we specify last 15 minutes. So we only look at the events that we are interested in. The reason I mentioned this, it's because it's very easy for a lot of people to lean on those defaults, especially when you're a beginner with SPL. But it's super important to remember that the functionality does exist in Splunk to search on very, very, very specific segments of time. So narrowing down the search time window will ensure that the less amount of data has to be searched through your query, and that will result in a much faster, much more efficient search job. And then, of course, you could use what we call the fields command, which is specified right here. You'll see it. So the fields command is a good way to reduce the number of the fields from your events that are being passed through the SPL pipeline for processing. You can specify the fields that you want included, or you can specify the fields that you want excluded. It'll all be up to you and what you want to build the query like. And then finally, as we discussed a minute ago, it's also best practice to place streaming commands, those commands that we just talked about earlier, and then non-streaming, the transforming ones like sort, later towards the end of the query. Then, of course, we've got more options here for how we can build those beginning searches. So if you guys think about narrowing down those events at the beginning of your query, how do you narrow down those events the best that you can do? So we've got those keywords. You can search for specific keywords or groups of words. So that's one option you have. You also can use Booleans. You have to keep in mind that Booleans do require you to write them in uppercase. So if you are using Booleans, just make sure they're uppercase. We've got phrases, so you can look up entire phrases rather than just keywords. So you can just put them in quotation marks and look for the specific phrase. You can also, this is the best thing we can do, is field searches. Specify the field, specify the value. So rather than using a keyword, you could use a field search, and that's going to be a little bit more efficient. In some cases, you cannot do that. It's not a field that we can extract. It's just the keyword in our event. So at that point, we would have to rely on just using the keyword. But if you can use those field searches, that's going to be an even better option. And then, of course, we've got wildcards. So although we don't recommend using wildcards just anywhere, there are times where they're going to be really, really useful. So if we know, for instance, here that the status code for our field status has to start with 40, and we don't really mind if it ends in it's like from 400 to 409, we can use that wildcard there to replace that last digit, and it'll actually look for those status codes where it starts with 40. In other cases, we want to avoid using those wildcards. For instance, when we are not super sure, like here, when we're using those keywords, if we know the keyword we're looking for is error, we don't want to put a wildcard after the two R's, because that'll actually return a lot more results than we initially needed. So we want to make sure that we focus those wildcards whenever we actually absolutely need them versus just using them anywhere, because that'll return way too many results. And then, of course, we've got comparisons. So similar to Booleans, we also have comparison operators, comparators. So we could have those status codes, for example, be greater than a number, or we could have our user field be anything other than a specific value, and so on and so forth. So these are also some little tips that you have here that you can use to write and narrow down those events at the beginning of your queries a lot better. And I highly, highly recommend you focus on using those field searches, and wherever possible, those comparisons or Booleans, those are going to be your best friends. Then, of course, we've got to have options for when we don't have our information in mind already. We don't really know what we're looking for quite yet. So that's when those wildcards, those phrases, those keywords will come in. That's going to give you a more generic view of the events, and then you can start narrowing down from there. So these are some tips and tricks. We also have more that is linked right here. So there's quick tips from optimization that you can find in our documentation page, and that'll actually have a lot more information here that you guys can look at. And these are just some examples that I put here on the slide so you can kind of understand what we are talking about here. So for instance, this very first search only uses keywords, right? So Splunk will return any events 503 and purchase are found anywhere in the text of the event. Then we've got another search where we're using a wildcard. So in this case, we could have used this one and it would have found the events we're looking for, but we didn't know that the events were going to say purchase. Maybe they would have said purchased, purchasing. We're not sure. So we're using that keyword, that wildcard there. But this is something we do more at the beginning and we'd narrow down later on. Because as you can imagine here, the events that are going to be returned are going to be a lot more than what would be returned from the very first search. Because now we have anything that starts with PUR, in addition to that 503 in the event, it'll be returned. And then we've got an example here in the third example with a Boolean. So in this case, we have a keyword, and then we've got that outside of this keyword, we also want to find either this keyword or that keyword or both. So now that's kind of how we can use those Booleans there. And last but not least, we've got the most efficient way to do it, which is those field name values. So we've got the status is 503, the action is purchase. This search will return the least amount of events, and they'll be narrowed down to exactly what we are looking for and what we're interested in. So I invite you to think about this question at the bottom here. How would you find events with a status code of 200 that are not purchase events? And here you can think about which one of these two queries may be more efficient, right? And in this case, for this specific session, what I'll do is I'll give you the answer. And the answer is actually the second one. And the reason for that is that if we think about how Splunk will process this in the backend, this first query will return any events where the status is 200. That's going to be the same for both. And in this case, it's going to return the events where we do not have a field called action that has a value of purchase. Now, pay attention to how I just phrased that. It will not include any events where there's a field name action with a value of purchase. Whereas this one is going to return any events with a status of 200 where there's an action field that does not equal purchase. So the difference here is that if there is no action field that exists in the event at all, the action field is not even there, it'll be returned for the first query, but not the second. The second one specifies that the action field should be there. It just should not have a value of purchase. Whereas this other query is saying, do not include events with action equals purchase. So if action doesn't exist, that still falls into that logic. So that events still would be returned. So then in theory, they both do the same. You'll get your results either way. You'll be able to see the events you're looking for either way. But the first query will be a little bit less efficient because it'll include more events in there than we originally intended. And that is the beginning or the intro to SPL, the SPL queries and how they are processed in the backend. So now that you have a better understanding of writing SPL searches and how you can make those more efficient, you can now start diving into knowledge objects and then eventually some specific commands that are popular here in SPL. So make sure to return for session 4. We'll discuss those knowledge objects and integrations, and we'll start talking about more of these commands and how we can actually use them for our use cases. Thank you so much.